now we will move to our last guest, Matějka from the Institute of the Chemical Processes of the Academy of Science, who has prepared a very interesting topic, recycling neodymium iron bor magnets, which are used in electric vehicles, wind generators, etc., and etc. Mr. Matějka, stage is yours.
Thank you very much. Thank you for introduction. Hello, everyone. I really want to thanks for invitation from Nordic Chamber of Commerce, especially to La Turcerova. Thank you for this opportunity to have to be able to speak about recycling neodymium iron bor magnets and NIB magnets. My name is Jan Matějka. I'm CEO at HM Personal Progress. So I need to correct that information that I'm from Academy of Science. It's not true. We are cooperating, but I think it's not the issue to discuss here because the most important issue is recycling neodymium iron bor magnets. So let's get on straight. So great. So what and where is neodymium magnet? Neodymium magnet is when you have quite a huge range of magnets. Neodymium magnet is based on REE, rare earth elements, which are giving to this magnet quite unique properties. It's about remanence. It's because of these properties, the remanence is the strength and it's how strong the magnet is. And these magnets based on neodymium, they are the strongest magnets on the planet Earth, and for that reason they are quite great to use in electric motors. What is opposite side of these magnets and of this remanence, this strength, is that they are very fragile to temperature, because they can be demagnetized from 80 degrees of Celsius to up to, let's say, 220. It depends what you put in them, what another elements you put in this magnet, and because of this it is quite expensive at the end of the process. So this is what it is, what's magnets, and where they can be found. It's electromotors. It's now growing and growing. The share where they are used. It's electromobility. So when you are in, let's say, in Prague, and you can see the shared electro scooters. So in every electro scooter there is a motor which is based on this NIB magnets. But it's not only in the, let's say, motors or generators, wind generators, which are powering, let's say, this Green Deal movement and green energy. It also can be used in separators and lifting magnets. So it's the scale and the areas where you can find those magnets, it's very wide. So that's just before beginning what is neodymium iron bor magnets. So the main thing is why to recycling NIB magnets. It's the problem, as I here wrote, it's mining and extraction processes cause environmental issues. It's very problematic to extract those elements from the ore, because you have in the ore around 1 point something to 2 point something % of these REE elements in the ore, and you need to use quite a lot of chemicals to extract them. So for that reason, there is a very few places where you are able to extract those elements, and mainly it is in China. For that reason, you can see that China holds around 95% of the market with these elements, because no one else wants to cause environmental issues in their countries. What is obvious. So this is also a huge motivator for finding ways how to recycling it. Why recycle those magnets is also that 30% of mass of that magnet is are those REEs, which can be extract, let's say, up to 95% of them, because you can't do anything, let's say, up to 100%. It's impossible. So there is a huge source for this REE to let's say to again extract it. What will be very another good point out point of this, if we will be able, because we are still not able to extract those REEs, is if you have it, you can use it, reuse it. So, and don't be dependent on the China, because also it's very problematic to have a partner who is holding 95% of the market. It can dictate it, the price, the volumes, and so on. And for the business point of view, it's very dangerous. So this is also a driver to find a way for recycling the magnets. There are several approaches of recycling. First of all, and quite a lot of institutions are going in the way of hydrogen decapitation. I really don't want to go and bother you with what it is. So I just only say that there are some approaches, and I hopefully, if you want to know more, just send me the questions, and I will be happy to answer them. So then it's hydrometallurgy process. It's the way which we are using, and then pyrolysis. Still, as I mentioned, the race is on in this. No one is in the end. No one is in the finish. No one has the final product. It's still it depends on the approaches. Every approaches will provide another end product or final product, which can be used in the industry once again. So this is what where we are at the moment. So, but still, I will I will repeat myself on what was said by Daniel, because we are dealing with the same issues. It's the first is collecting. We already discussed it with Peter. It's problematic to collect it. It's a very small amount of magnets which are used in some applications. So it's even problematic to identify. It's problematic to find out the ways how to, let's say, cut out those magnets. It's problematic then to have, let's say, clear or not to have such a mixture. Like Daniel mentioned, it's problematic to have also paper and other stuff in the mixture, in the feedstock, because organic and inorganic chemistry don't like each other too much. So this is also the problem. So this is on the collecting side. The other stuff is processing. Each approach is dealing with the same thing, and at this stage I can see that we are in experiment. We are doing just only experiments, and those experiments are towards to have a pure end product, because it's also the thing. Our end product will be PRND, that's praseodymium, neodymium, and DY, it's dysprosium oxide, which has to be 99 plus % of purity. If it is less, it's problem, and we are not there at the moment. The recycling and neodymium magnets, it's one very crucial thing is to be pure as much as possible. Another experiments what we are now undergoing, it's taking it to the industrial scale level. Like Daniel has in his presentation, why it's just only 15 kilograms per hour, because it's experimental, and we are all dealing with experiments and analysis and so on, and it's so expensive that we need to be sure what we are doing, because it is possible, but it's not viable to have thousands of experiments with thousands of analyses, because it's very costly. But still, we hope that we are on the way to have quite pure end product, and we, after our 1 year, really like 1 year of experiments, in that, just not to have it in the glass, small glass scale, chemistry level of processing thing, that we know how to go upward and let's say scale it up. And at the end, we need to repeat it again and again, and it is about recycling something new. This is where we are, and with what we are dealing with. So, as I mentioned, where we are collecting feedstock, building the collecting chain for neodymium magnets up, and yes, I'm here also to ask politely, not only the panelists, but also any other people who are, let's say, in touch with devices with neodymium iron bor magnets, or they have in their devices this. If there is any help, is appreciated. It means I'm open to, let's say, fly, drive, wherever, to discuss the possibility how to cooperate to be able to collect those magnets, to be able to let's say, yes, to produce very pure oxides, and scale up this project to let's say on the industrial level. So this is our aim, because we are still a small startup, and we have limited resources, and any help is appreciated. So if you are interested to help and to know more, I'm really happy. I'm here. I'm happy to answer your questions. So from me, it's all. Thank you for your attention, and I'm open to answer your questions.
Thank you, Jan, for your presentation. When I will watch it, I was wondering what should be the main source of for the recycled magnets. Should be EV vehicles, EV scooters, as you mentioned, electric generators, or something else?
Well, its main source will be the chain. Once you create the chain, you will have you will have a very good source, and this is my main objective at the moment, to create up such a chain. In particular, in wind turbines, there is up to 600 kilograms of those magnets. So yes, this is the, let's say, the biggest applications what I have on the radar at the moment, and then it's going down, and you will have in Akku drillers, you have, let's say, 20-30 grams of magnets, so it's various. But the chain is the main option, main target.
With the battery recycling, we still haven't gotten the position when the industrial recycling of batteries makes sense. There are still very few of them. I understand from your presentation that the recycling of magnets has the same issue. It's still not enough amount of magnets to be recycled.
Actually, quite frankly, I'm not into this matter. I don't know. When I'm discussing with recyclers, they told to me that 1 kilogram of battery, lithium-ion battery, costs 83 Czech crowns to recycle. So it's I don't know how much it is on the market actually. I was also discussing this with colleagues from Academy of Science, because they done quite a lot of things, and they said this topic is for them over, because everything is let's say researched and developed. So for them it's not the topic anymore, and it can be, but I think it's if somebody is building around this business already, he need to discuss with Scania, with Volvo, with guys from Scania and Volvo, because there will be quite a lot of batteries. And again, from my point of view, it is about creating the chain. Once the chain is built up, then you will have quite a lot of battery, but to construct such a chain, it will take, let's say, 5 years from now. I think it's better to start now for them, because otherwise we will have batteries all over the place.
Okay. Thank you for your answers and presentation. So, ladies and gentlemen, thank you again for your participation and presentation in today's conference. I believe it has provided a lot of interesting information for those watching today's conference, and I have no choice but to bid you farewell. Thank you for your attention, and goodbye.